5 after, so let's get going. Can you folks hear me?
Yes.
Yeah.
Okay. Uh, Anybody wants to share their submissions or progress last week on the task? Steve, were you saying something?
Can you hear me okay?
Yes, now I can.
Yeah. The sound is a bit funny. It's sort of cutting out a wee bit.
Yeah, it seems.
Can I just share my screen here?
Yes, go ahead.
So-
Steve, are you sharing or is the computer stuck? Steve, are you there? Can the rest of you hear me?
Yeah.
Okay. Steam screen seems to be, or his computer seems to be stuck or something. Ah, he dropped out. No, he's still there. Do you want to try again, Steve? Can you hear us? Or can you hear me? No. Anybody else want to share while Steve takes a minute to figure out issues? Any luck, Gautam, with the LS team approach?
Yeah, I'm not really getting anywhere with that, to be honest. So I might just give up on LSTM. and move on to BERT or something. So yeah, I'm the best I'm achieving is just 0.5, and yeah, it's also severely overfitting. Like the training loss is, it's similar to the one that you had shown many weeks ago. The validation loss quickly starts increasing, and uh, yeah, the training loss is just keeping on going down. Yeah, I'm not able to get great results with LSTMs. But I did see the link that Yuri just shared. Someone got 0.16 with LSTMs, but I can
Yeah,
also see that.
one.
Yeah,
Yeah, so yeah, I mean, generally, I want to wait until we have kind of tried a bunch of things before we look at the best results. So,
no,
but
I was
yes,
just saying, like, in the sense that LSTMs are still capable of. I thought that it's. I mean, LSTMs are just not powerful enough to. But yeah, since he got 0.18, maybe I would have to work even more on this.
yeah,
But
no,
I,
I think
yeah,
I was going to tell you that, yeah, it generally, it seemed, again, I didn't look at specific examples, but um, I also concur with what you just said, which is um, LSTM seem to have given better scores than even where um, Steve was at with Bert. At least as of last week, he was at point 0.2, something lower than where I was at, which is at 0.28 or 7 or something. But he was even further down. But to your point, I think I saw generally that there were better scores of even in the point one kind of thing. So, but the point I was going to make was in general, it seems like word level models matter and not so much the sentence level, but with word levels and LSTMs and some specific I don't know what they are, but some specific features like feature engineering based on number of characters or where I TF-IDF and I mean those are simple ideas, but maybe even more complex feature generation and then throw them along with your word vectors into the LSTM. Ah, Steve is back.
Yeah, sorry about that. My computer just crashed there.
Ah, okay. Yeah, I was like,
My computer crashed. It takes me about 5 minutes to restart. It's really slow to reboot. So, yeah, I was just going to show you. I haven't actually done a lot since last week, but yeah, last week I was like, can you see my screen there?
yes, yes, we can.
Yeah, so the one that's highlighted here, this is where I was last week. So like that was using like normal BERT, with just like the standard questions in their standard order. So I tried, the trick of doubling up the data set by swapping the order. But when I do that, I get like a much, much worse score, which
Oh,
is
wow.
this line here. I don't know why. So, so then I moved on. It takes like with standard BERT, it takes like a long time to train. It takes, I don't know, like an hour and 15 minutes or something for each epoch. Like obviously when you like double the size by swapping the questions, it takes even longer. So I moved on to DistillBERT, which is this. And yeah, like originally when I tried it, I had the problem that with Hugging Face, with Hugging Face, they've got their whatever it's called, their auto thing to generate the encodings, the embeddings, and like the masks. And like originally, I'd wondered why it wasn't giving me like any mask for the question pairs, or like it wouldn't accept one. But there's actually something in the DistillBERT thing that says that they don't use any question mask when they're doing those. And so yeah, so this is just running. So like it's just got like the embeddings for the tokens, does a tokenization, and it gives you like the attention mask, but there's no mask for which question is which. But like with this, yeah, DistillBERT, it trains in half the time of normal BERT, so this is about half an hour for each epoch, so it's like a lot better to run. yeah, so like I tried that. Then
Is that compared to?
Also, sorry, question while you're still there. So it seemed like even on Distilbert, you got better results without the swapping than with swapping, right? That continues to be the pattern.
yeah, that's right. And somewhere down here. Oh yeah, so that was swapping it with standard BERT. And then I went to Distilbert, and this is with swapped. So yeah, so again, that's like double the training size, and you can see the scores are still pretty bad. So then what I did, rather than having, rather than swapping the questions and like doubling the size of the training set, I ran 2 separate models. So like I trained one of them here, like that's on sort of the standard order of the questions, and then I swapped the questions and like trained again. So like I got similar scores with both models, and then I took the average of the results, which gave me this, or this one, I can't remember, but you can see, so like, yeah, so having 2 separate models and then taking the average of the results, it gave me like my lowest score that I could get. And then, yeah, like finally I tried again increasing the number of epochs on it, but so like that's for 2 epochs, I think it is, and then I went for 3 epochs. And as soon as I could train for like an extra one, the scores get worse. But yeah, so like that's the sort. So this one here is the best score I've got so far, which is Distilbert with 2 models and like averaging. So one of them's the standard question order and one of them's the swapped question order.
So you average the score?
That's right, yeah. So yeah, so on the test data, I stick it through each model, and then average the scores, and then produce the final submission.
I have a quick question. You mentioned that Distilbert was twice as fast. Is that compared to BERT in Hugging Face?
Yeah, yep. Yeah, so this is all in Hugging Face now.
Okay. I have a more general question. Do you guys understand why Hugging Face is faster than BERT from Google? If it's not using distillation by default, it's just a kind of better software, or?
I'm not sure. I don't know. Sorry. I don't know. I don't know. Is it much faster? I didn't really sort of compare them, but yeah, like I have run. Yeah, like I started off with the TensorFlow one, and yeah, the Hugging Face one maybe did seem a bit faster, but I'm not sure. Like obviously, I'm going from TensorFlow to PyTorch then as well, so.
But wasn't like a quarter of magnitude faster.
I would have to go back and like look and see exactly how long it took.
Okay, no, mind. I just thought maybe you know.
No, I'm not sure. Sorry, but yeah, like obviously, like Hugging Face, you can like get it to work in Keras as well. So like to work in the TensorFlow way. So perhaps I could compare the Hugging Face's TensorFlow version against the standard TensorFlow one and see are there any difference. But I'm not sure. Sorry, but either way, it takes a long time.
Okay.
I saw that. Oh, sorry.
Sorry, on the ensembling, Steve. So you predicted using each of the 2 models and then average the final scores, or you predicted the average? Well, yeah, there are only 2 models, so it's more the averaging of the scores.
Yeah. So. Yeah, so if you can see here, so this is one of the ones that models it. Yeah, so I've got like the 2 models. Yeah, so like basically it sticks the test data through each model and like stores the logits. and then like, yeah, I take the softmax of those and then average on that. Yeah, so it's like it's averaging on the probabilities of the is duplicate.
Okay. So it's not a final score, but the averaging, like you said, the probabilities of the two model outputs.
Yeah, like if I just had a single model, this result one, this would be my is duplicate score.
Right.
So yeah, so like it's like something like 0.7. It's predicting the probability of if it thinks it's a duplicate or not. So I have basically like an is duplicate column for each model, and then I average that. I also tried like thresholding as well, because I thought that yeah, like obviously something like this thing here, this one that says it's like 0.99% sure it's like a duplicate. I thought, well, obviously it thinks that that is a duplicate, so if I stick that to like 1.0 instead of 0.9, that I would get a better score. But it actually, I ended up with worse scores when I tried to do that. So yeah, like when I thresholded the scores, for whatever reason, I ended up with a worse score, but I don't know why.
Yeah, I've seen similar thing when, of course, I am not talking about, I think when I did the cosine distance stuff, I tried something like that, and it actually was worse when I tried to try different thresholds. But that was for distance.
Yeah, because you'd think that, yeah, like again, like in this one here, is this a duplicate? Yeah, it's like 0.009. So obviously it thinks that's not a duplicate. And so you'd think if you just like stuck that to 0, like you would think that in the sort of the golden results that must be at 0. So you'd think if you just put 0 in there instead of 0.009, that you'd be closer to the true result and get a better score. But yeah, like that's what I was trying here, but I ended up getting worse scores, so I don't understand why that is.
What is the metric that this is getting evaluated on finally on the leaderboard? Do you remember, Steve?
I can't remember, sorry.
The log
Log
of
loss.
log loss, yeah.
Yeah.
So then 0 and 1 will be bad, right?
But are you not trying to get as close? Yeah, so like
0 and 1 just means you are that much more confident, right? If something is actually 0 and you're predicting 0, that means your model is really good.
yeah, so it just like says it's log loss.
Yeah, you
But
can
yeah.
just,
Yeah, so like, yeah, I
search
thought it
for
was,
log
but
loss in
basically you're saying,
Kaggle, it gives you the actual equation. Yeah, the link is broken, but search for log loss in Kaggle itself. I think, Steve, I found a link which gives that.
Right.
Yeah.
So basically, it would be cross entropy loss, right? That is the loss.
Yeah. You train with that. Yes.
So,
but like in the training set, so like there is duplicate, that there's just like a binary value, isn't it? Like it's either 0 or 1. So I presume in the golden test results, that's also 0 or 1. So like when you submit your predictions, you would think that, yeah, so like if this one is right and that is a duplicate, so like here it's like saying the probability of it being a duplicate is 0.99. So you're 99% certain that's a duplicate. So you'd think if you stuck that to 1.0 and said, yes, I'm definitely a duplicate, that your log loss would be less and you'd think you'd get a better score.
Yeah, that's what I'm kind of confused. Correct me if I'm wrong. Let me just share the link so you can pull that up too. And if you look at the log loss, I just put it in the chat. Sorry, on Zoom. did it turn out to be that? Oh, sorry. Right, so if you scroll down, right there, yeah.
What, that?
Sorry, above, slightly above, I just missed it. Yeah.
Oh, yeah.
So my understanding is that if you stick in 1, it's going to become 1 minus p, right? Like if it's the swapped out thing, or if it's 0, it will be 0. So then you're basically calculating like either log of 0 or log of 1. Isn't that bad? So the y's outside is basically the actual class, right? So y would be, like you said, the golden set will have the y, which will be either 0 or 1.
Yep.
And p is the probability that you are predicting from your model.
Yep.
So if that p turns out to be 0 or 1, doesn't that kind of make it worse? It should end up by calculating like log 1, log 0, right? Isn't that bad? Am I missing something?
So in the first case, for example, if y is 1, then you'd get log of p, and p is also 1, right?
Correct, correct.
So, so it would just be log 1.
Which will be 0, right?
Yeah, we want lower values, right?
Yep.
That's a good thing.
Yeah, so it will be low, right? Because if y is 1, then 1 minus 1, so the right side is
that will
0
not be
anyway.
there, right?
And then if you put log 1, which is 0, then y is 1. And if p is 1, which is what Steve made p to be 1 instead of 0.99, then that'll become negative of 0, right? Versus log of 0.99 will be something negative.
Right.
And that negative multiplied by minus 1 would make it a slightly positive number, wouldn't it?
Negative of that negative, yes. So that should become a positive number.
So to Gautam's point, if you want lower, then 0 is lower than slightly positive number. So isn't that good?
Yeah, that's true. I'm wondering then why Steve is getting worse results with that.
Yeah.
Aren't you effectively like taking logarithm of 0, which is infinity?
That would happen only if you misclassify something, right?
Yeah.
Which is possible, yeah, that's true. So yeah, that could happen also. The log of 0 will only get activated only if you happen to misclassify something.
Yeah, like obviously if this one here, this 0.99, if it's really not a duplicate and it should have a score of 0, then if I stick this to 1, it'll obviously make things worse. But
right, yeah, that way, yes, correct.
Yeah.
Okay.
But yeah, because like initially I tried having like a threshold of 0.5, and yeah, just anything less than 0.5 I stuck to 0, and like anything above I stuck to 1, which obviously, yeah, like there you probably are getting like a lot wrong. But then I thought I would try it with the ones that are, which you would think are definitely duplicates or whatever, but perhaps they're not then. But yeah, it didn't help it for me.
And the 0.5 thresholding also gave you worse results?
Oh, it gave me much worse, yeah.
Worse,
yeah. Whereas I taken, like here, I took it to, I think it was like, if it was like greater than 0.99 or whatever, I would stick to 1. And if it was like less than like 0.01, I would put to 0. But even with that, I was getting worse. But perhaps it's just because I've got bad results. Perhaps my predictions are bad to start with.
Those ones may be getting flipped. Yeah, that's interesting. I still don't understand why.
Yeah.
I had one more follow-up question was, oh yeah, two actually, with respect to like you're having two different models there. One is you train it with the questions, and the second one you train it with the swapped questions, right?
Yes.
When you predict, do you predict with question and swapped question, or do you just predict with just question?
Just with question at the minute.
Okay, I see. Okay.
Yeah, so like there's two models, one's swapped, one's not swapped.
But the test is the same one.
Yeah, the test is just in the standard order. So yeah, I could swap the test as well.
Right. So would that change the result?
I don't think it would change the. I don't think it would change the result, but it would obviously. I could use that as like another average or whatever. I could get the one result with the questions in their normal order, and then swap them and stick them through both models again, and like take the average of that. And so you're probably sort of getting more confident in your
because
prediction.
You do truncate at some point of time the length of the question, right?
Yeah, there's
okay.
Yeah, up above. I can't remember, somewhere in the training there, like it's
yeah, the max length. Like
yeah,
maximum number of tokens that is there in the sentence. There, max length.
Yeah, there. So yeah, so like at the minute I'm using a pretty short max length on the tokenizer. So yeah, I could try these other longer lengths.
But so your test also gets truncated to that, right?
Yeah, it will. Yeah.
So swapping will probably change results to some extent then, right?
Possibly, yeah, because I think
if
so like
anything
this
is
max
greater
length,
than 128, then probably. Otherwise, it should not, I guess.
Yeah, we were saying about this last week. It's like so you've got the two questions, and you got like question one gets tokenized, and then the separator token goes in, and then question two gets tokenized, and I wasn't sure like last week. Say like question one's really long, close to 128. Will question two's tokens then be truncated? Question one will be in there fully, but question two would be truncated. Whereas, yeah, like then if you swap the questions, it'll be the other way around. The question two, all its tokens will be there, but question one will only have a few of its tokens. As opposed to some of the earlier versions I tried, it manually assembled the tokenized string, and so like with it truncated each question separately. So like I think it tokenized question one and then truncated at 50 tokens, say, and then it did the same with question two, and so like it meant that you always had, if they were truncated, it sort of did it equally to each question. Whereas I think with this method here, I think it'll be chopping the end off question two.
I see. Okay.
So yeah, that could have an impact on it.
Cool.
Yeah, I saw Yuri's post about the order of the notebooks within Kaggle. I'd been caught out by that as well. Like when you go to Kaggle and like you go to the competition and then sort the notebooks, yeah, it gives you the worst one as the top of the list. But I found this notebook. Not sure. Yeah, so like this is using like LSTM with Glove, and like it got a pretty good score, rather than your like using Yuri's method of sort of changing the URL to find the better notebooks. I just like scrolled down and like found this one. I'm not sure, but like this one, I haven't actually got this to work yet, but it did seem to get like pretty good scores.
By the way, did it change or was it always like this?
I'm not sure. I hadn't looked before, but yeah, as you say, like if you go here and you go to best score.
Best score, yeah. Then
because the losses, I mean, the metric is loss.
Then you get one. Yeah, you get one with the worst score. But yeah, so just within here, yeah, like this one here. So you can see like this is a pretty good score. And like this is an LSTM with glove. Unfortunately, it's not a notebook, which is what was causing me problems. It's just like a Python file, and plus as well, it seems to be missing some of its inputs. But if you search about, they're in there as well. But yeah, so I'm not sure. Is this like your notebook, Gautam, or whatever? It's like an LSTM with glove stuff. I haven't actually looked at it that well, but as I say, it's got a very good score on it. So it might be worth you looking at this to see how it compares with yours.
But I noticed that this guy used some kind of test leaks to improve his score.
Oh, did he? Yeah. As I say,
Yeah.
I hadn't really looked at the details of it, but yeah, I just saw his score and thought it like sounded pretty good.
Yeah, in fact, he has an input called magic input or something, along with the
Does it?
express. Yeah, apparently there are some leaks. Yeah,
No doubt the
Oh,
inputs are missing.
yeah. Well, that's where
No,
I'm going wrong.
but sorry, but in this competition though, 3 years back and generically, because when I was doing the first week EDA, the magic word shouldn't be, there should be overwhelming negative connotation, at least with respect to this competition, because I think a lot of the EDA stuff and people refer to the individual feature engineering that multiple folks have done as magic features, because at least different people, including this guy, use different set of features or subset of features, and each person, um, when I did the EDA, there was a collection of notebooks which seemed to say, here are all the set of features that people used, and people kept contributing to it, and then some people collected them together and referred to them as magic features, because there wasn't, the explanation of only some of them made sense, but others, by that I mean other features people continue to use, which were hard to find why they contributed to the better scores. So my point is that magic features didn't always, in the context of this competition, mean that they were hidden or they were. It just meant that people customized and discovered features and kind of incorporated them in the model. The reasoning behind it was always not well explained or thought through.
Yeah, from what I've seen of his notebook here, yeah, so like the only inputs he has are the questions from the competition plus like the glove embeddings. So he's not actually bringing anything else in. He
Yeah,
does like a lot of this thing where he's like
right,
splitting
right.
up the tokens and
Process,
stuff.
but
And
he does use, to Gautam's point, Steve. When I looked at it, it's been a while, but I thought he did something called leaks, where actually that isn't, yeah, right there. Isn't that something that where he creates a set of features which he takes, yeah, right there, leaks. You see that test leak or leaks, but just because
yeah,
he leaks doesn't mean that they are wrong. That's what I was trying to get at, because these are just intersections and the frequencies when you apply. And if you look at what he's trying to do, he's just trying to get the intersection of each row between question one and question two. And I don't think that that's improper to do.
yeah, like normally,
Or
like in a Kaggle competition, when people say it's leaky, it means that they've found some other data set that's external and they're using that or whatever, where they've like found a sort of another data set which improves their model. Whereas
right,
like, yeah, this does just look to be some type of feature engineering, doesn't it?
exactly. So that's what I found, that he's just, even though he calls them leaks, but if you look at it, he's just taking it from question one and question two. So, I don't see why figuring out the intersection or figuring out, you know, I don't know what he's doing here. Adding, I think in this case, he probably, because again, if I recall, these are it's been a while, but if I recall, these are post words. So he's trying to see commonality of words or something in the dictionary, maybe,
Yeah.
question one and question two, and then the intersection of the set of words in the questions. And those things I don't believe are, other than, as I said, if we were to dive into why do these features or why should these particular set of three things be used as leaky features, I don't know whether he has an explanation for that, but there's nothing wrong with what
Isn't
he's
the
doing.
isn't the weird thing that he's using TF test over there, and I'm assuming that is the test data set? Like
Yes,
that is
but
kind
that's
of considered wrong, right?
But that's only test leaks, and I don't know whether he uses the test leaks in the. It would only be wrong if he uses the test leaks when he trains the model, though, right?
Or if he's collecting features of that either, right? So somewhere that's what my understanding of leak is, right? Like you're pulling something from
Yeah,
a
if you
test,
pull it from test into train, then yes.
right?
But
You're saying he's just applying whatever feature engineering he's doing to train, he's just doing that to test too.
yeah,
Oh,
that's my
okay. That
understanding.
way, okay, I see.
So see, he even, I mean, what's wrong is I wish he had called leaks train leaks, because that's what he's doing, right? Exactly. If you see, it's the duplicate of that. Now, what I don't know, and Steve, we may need to go down to see whether he uses the test leaks in his training. Then I would agree with you.
Yeah, I'm not sure. So is it?
To go down further, I think
Yeah,
he had,
he seems to have kept them separated as test leaks and leaks.
right. So as long as he does that, then there shouldn't be a
Yeah,
problem, right?
I guess. Yeah, that's
I
right.
haven't looked. You'll need to keep going further down where he's training. Yeah, hang on a second. Right there, right there. Hold on. Here, see if he's the magic input is what is. You go up a little bit, Steve, then you can see that magic. Hang on a second, right there. So it's just the leaks shape. He hasn't used test leaks, right? So as long as he doesn't use test leak and he just use leaks in what he does in the training, then I don't think that that's a problem. That's actually, even though he calls it leaks, I don't know why he named it that way, but it's not leaks in the sense that Steve was just explaining, right? He's not leaking info from the test data into the training data. At least that's my understanding. I mean, I'm saying it as a statement, but I should pose it more as a question. That's at least the reason why I didn't interpret, even though he labeled it leaks, that it was just feature engineering.
Yeah, I haven't looked that closely. I know in the comments down below, people have asked him why he called it leaks and stuff, and he hasn't mentioned it. He also uses, I can't remember where they are. There's he uses a couple of sort of hard-coded values. Yeah, these
Yeah,
things
those
here.
those Steve
Yeah,
I had covered last time,
somebody
right?
asked.
Like,
Somebody asked where these came from, and he didn't answer that. I don't know what these.
yeah, so those I can tell you what they are, right? It's just what I said last week with respect to the weights. This is the ratio of zeros and ones in the test set. And
Oh right,
remember,
yeah. Oh yeah, yep. I remember now. Yeah,
that's those are class weights of zeros
yep.
and one test. So that's what that is.
Right.
Okay. And by the way, I spent some time finding out, the mystery which we left open, or at least I searched it, and there's no good answer yet, which is if you go down a little bit further and just a little further where he's actually doing the history. Yeah, and you also, sorry, if you also see the class weight, right? So it's the same thing as I was mentioning last week. So he has the class weight,
Yep.
and those are the same as what he used above. And then if you just hold there, you'll see that just like what I had done, he has used class weight as class weight and then also given a weight val to the validation data. And I spent a bunch of time looking at any further explanation than what Keras gives on this weight
On the
val.
thing.
Yeah, and I couldn't find it now. I didn't spend time last week, running experiments with dropping the weight val and only doing it with class weight, and or having weight val and not giving class weight. I didn't do that, but at least both seem to be, or I should say, in this competition, at least it seemed both things used together. But a good explanation of what this weight val does is, if somebody finds something, I spend some time searching TensorFlow, Stack Overflow. No, in fact, what is strange is the questions on exact explanations of weight val are still pending or open in Stack Overflow. Nobody has answered them. Or where it's answered, it doesn't give you a crisp, clear answer of what it does or doesn't do.
I see here in his model fit, he's got the leaks.
Yes, but as long as he uses training leaks, then he should be fine.
Right. Okay.
So one more general question with respect to, you said you combine both the data sets, and when you trained one single model with the swapped questions and unswapped questions, you were getting worse results, right?
Yep.
I was just curious, anyone has any insight as to why they're like a batch size issue, maybe more number of epochs? Anyone have any insight on?
Sorry, Steve, can you return there to that for a minute? I just wanted to make one point before. So if you look here, Steve, to Rekhal's discussion with you, he does the predictions, swapping the test questions, and then averages the predictions. You see that?
Yep. Yep. I'll see that there. Yeah. Yeah, Rekhal, I tried yeah, so I tried like swapping the questions, which doubled the training size, and then I got worse results. And so I thought, oh yeah, like maybe it's because of the fact that like my training set has increased in size. And so like then I increased the number of epochs to try and compensate for that. But yeah, I still got worse results. And the other thing I did was because of the fact like normally like when I'm running it, I only run for like 2 epochs of training. And so like I'm not adjusting the sort of the hyperparameters or whatever. And so like I don't really need like a validation set. So I thought I would use the entire training data to train the network rather than sort of taking 20% off for a validation set. And so I did that as well. So I used all the training data to train the network. And again, I got a worse score. So it seemed to be the more data I have, the worse the score gets, which is bizarre as well.
That's intriguing. Yeah, that's what I was curious if anyone had.
Yeah, that's a very good question, because not I haven't done the glove word vector based thing. I was actually going to try a CNN with a glove embedding and see how that worked too. But it's kind of interesting that we're seeing worse results with increased training data.
Yeah, so like here previously I was chopping a bit off for the validation set, whereas now I ran with this, like just using the entire training set to train with, and yeah, got a worse result. So yeah.
And you're still using, and you said you increased the epochs and still it didn't get better, right?
Yeah, so like I used the entire training set. Yeah, so I think this is like the best result, and then I used the entire training set and got a slightly worse result here. And then I thought, okay, well, I'll increase the number of epochs. So I did that, and then I got this, which was even worse. Yeah. So yeah, I'm heading in the wrong direction now.
With the batch size is being kept same throughout here, Steve?
It was, yeah.
And I'm assuming shuffle is on for all of these.
Is there a shuffle on it?
Yeah. Or is there no shuffle on it?
I'm not sure.
Oh, okay. Yeah, I was kind of facing the same thing, but mine was with respect to images. I've been very curious as to what is going on.
Yeah, I don't know, is there any shuffle at all? Yeah, because it's like it's using like this Hugging Face thing, I think. So I don't know if it does any shuffling.
What's the sampling, random sampling though? Wouldn't that?
I presume that, yeah, these are all sort of straight out of the Hugging Face sort of sample program. I presume it's doing, because then we got this other one. Yeah.
So this would seem to say that you are sampling, which is equivalent to shuffling, right?
I'm not sure. Isn't sampling weighting though? I'm kind of confused now. I don't remember what exactly sampling.
Yeah, no, I thought sampler, like, if, again, this is not fast AI, so, but
this is PyTorch
sampler
though,
is
I
just
think.
sampling.
Yeah, so that's what. So sampling at what ratio, right? So that's like based on a class weighted ratio or something like that is what it would do, right? That's why you're not passing like length. So you're passing in trained data. I don't know what is happening. I need to look at that.
Yeah, I need to look at what random sampler of
that's coming from PyTorch.
Yeah, so it's actually a PyTorch thing, yeah.
So yeah, I think the PyTorch sampler is more to do with how you pick in one batch rather than shuffle, I think. Anyway, cool.
Yep.
Yeah, those are some interesting results, Steve.
Yeah, so some of them were a bit unusual, whatever. So
yeah, what this competition in some sense seems to suggest is quite a bit different from, if you just went straight through breeding BERT and the newer techniques, you would think that a task like this, by that I mean the Quora question pair thing, should just use BERT or even USE or SBERT or something, and it's like out is going to pop a better score than what people got 3 years back, and you're getting clobbered by feature engineering.
yeah, like that's the thing. When you look at sort of the state of the art results, it would suggest that BERT is the way to go, or some advancement of BERT that's happened recently. But like, yeah, when you try to sort of get to the top of the Kaggle leaderboard using it, all of the stuff that people did there to get themselves up the Kaggle leaderboard seems to beat it.
Yeah, especially for this task. I think, if it's just traditional classification or sentiment classification or something, then it may be, just use BERT and out pop something, or the neural language inference, things that it's already been trained to do. But this task falls between kind of couple of different tasks, semantic similarity and one other I keep forgetting. And that's what makes this problem a particularly interesting one, because none of the techniques like BERT or use or SBERT or, works right out of the box. At least even beats any of the other things that people have done 3 years back out of the box, because that's kind of, in some sense, the goal, right, for NLP to be generalizable enough that it's not so task specific that, okay, sentiment classification and classification works, but when you're trying to do tasks like this, which is comparing two questions, then it just kind of like falls apart without a lot of additional features. Or we don't know yet how best to exploit BERT for this task. Which to me is very interesting. Sorry, anybody else? Sorry, go ahead, Steve.
I was just going to say, yeah, like the guy that the notebook I was just showing there, I thought I might be able to steal some of his ideas and like incorporate them into my BERT model and see will that improve the BERT model? Because he's obviously he's using LSTMs with Glove, which is sort of similar and sort of it's sort of one generation behind BERT, isn't it? So perhaps with his ideas on BERT, I might get a better score.
Yeah, no, that's an excellent thought. Whether if you just use his leaks features with and combined it with BERT, what score would you get? And would you get it comparable to his? Yeah. Anybody else want to share any other thoughts? Unfortunately, I wasn't able to do much. I was headed down the path of doing something like using Glove, and at least initially I wanted to try convolutional networks, but I haven't gotten it working yet. So hopefully I'll have some results next week. And I think the two other techniques that nobody has used yet and are one, the Siamese network, and another one I saw was auto-regressive stuff applied to this problem. And those two techniques seem to be out there, along with, at least LSTM Gautam has been trying. I'm hoping to get CNN network working. Because that idea hasn't been tried, so I thought I'd give it a shot. And then, I would suggest people try either of Siamese network or auto variable networks.
Yeah, so you mentioned last time I start looking into Siamese network. So I haven't done any work. That's first time I've heard. So I just at the moment on a research mode, but I certainly will try on the Siamese and then see if I can find something.
Yeah, because I think if I'm not mistaken, I did post a link. If not, I'll repost it because sometimes it gets lost. Dinesh, I'll repost a couple of links on Siamese that people have attempted, or at least papers that is relevant directly to this problem. I'm just curious with various techniques, what people get and, to what extent we are able to get. And then eventually we'll start looking at kind of state of the art and what are the best, the notebooks as you reposted, kind of the best notebooks and what approaches they took. And exactly to Steve's point, also how much of that can be added to things that work. That's why I was saying, even to Gautam's approach, I think, if he can probably combine with his LSTM some of what this particular guy has done with the leaks and see whether he gets, suddenly from 0.5, he jumps down to 0.18 or 0.2 or something. I don't know whether that'll happen, but it kind of would be interesting to try.
Yeah, let me try on a Siamese and see what can I do. It's a good exercise.
Yeah, that'd be cool. Okay, any other thoughts?
Yeah, so I looked at this XGBoost notebook a little bit, just because it was like fascinating that it was giving such a low score. But it seems to be magic, right? That you just load data and it gives you the answer, and then he like looks at like basically he keeps changing parameters of XGBoost to like find the right features. And so I don't think it's like a good method of doing this unless you like know XGBoost really well. But yeah, it was just like trying to like see if it's a generally good method.
I think it's like, besides feature engineering, is also kind of parameter tweaking or hyperparameter customization. So it's not generically reproducible. It's kind of all fine tuning of things.
Yeah, and what I did is I translated it from Chinese using Google Translate, So I'll try to share it just so it's easier to
That'd be
read.
cool.
Just adding to that, and I think Yuri Cherny also kind of shares the same view. And that's why you kind of see him teaching random forests, which is like more robust and not so finicky with parameters. Whereas XGBoost, like you said, yeah, you really need to know kind of all the tricks and tips over there.
Yeah, I've
It's
seen this
a lot
approach
more
before. Like
finicky.
basically, you want to get somewhat like decent score with random forest, and then
Mhm.
if that works, then that's when you go and XGBoost it.
A lot more, yeah.
Interesting. Okay. Great. Anybody else? Last call. Okay, let's take one more crack. Hopefully, a couple of us would have done. I definitely wasn't able to do anything last week. Hopefully, that'll change, and we'll have some interesting results to discuss next week. Let's hope to get to the 0.1 range by next week, if we can. All right.